I'll start this question by writing out the relation just again to keep it. It's one of those things that can be kind of tricky, so it's a good idea to keep writing it out so that you get practice remembering it and using the whole thing. So here's the relation I'm going to be working with. And this time I'm going to be looking for it at x equals 3. So the first thing I need to do is figure out this value here. What is the inverse value at 3? If that's the case, that means what I need to do is find, if this is the x value in the inverse, then I know that it's going to be the y value in the function. So I can set up an equation to figure out what that value of x is, and that'll be when 3 is equal to x squared minus 8x plus 10. So let's rearrange and try to solve this. And when I move it to the other side, I'm going to end up with plus 7. So I can factor this, be x minus 7 and x minus 1. So I have two possibilities, x equals 7 and x equals 1. And if you think about the parabola, let's say we drew it like this, and let's say these were our answers here, and this is at x equals 7, and this would be x equals 1, then we're working on the left half is what it says. So this is the value that I want. I want everything on the left side. So I want to use x equals 1. So that means if x equals 1 here, then I know that y equals 1 there. So the inverse value of 3 is 1. Okay, so now let's continue with this question. We'll update the relationship here. So this will be f prime at 1. And the derivative here, it's a nice derivative to take, nice simple polynomial. It's negative 2x minus 8. So the derivative at 1 is going to be 2 minus 8, which is negative 6. So that leaves me with a negative 1 over 6. And that, of course, is b.